Hello class, this is Mr. Hart, and in this podcast we want to finish up the forces unit and talk about friction forces. Okay, so we have a basic understanding of what friction is and why it's there, but we want to really focus on how we calculate how much friction there is and how we describe this friction between surfaces. Okay, and so the first idea is that if you think about friction, right, it's this idea that when two surfaces are trying to move past each other, there's bumps in the surfaces that cause them to resist movement, right? Because they get stuck and things like that, which causes friction. Okay, but we want to be able to describe how much friction there is, but we have a problem because it's going to be dependent not on just one surface. It's going to be dependent on both surfaces. Okay, not just it's on ice or it's on wood, but also what's sliding along the top of that. Is that smooth? Is it rough? Is it rock? Is it what is it? So it's not going to depend on just a single surface. So we can't just assign a number to an individual surface. We have to assign it to two surfaces compared to each other. Okay, and that number is what we call the coefficient of friction. Okay, and the coefficient of friction we represent with the letter mu. Okay, the Greek letter mu sub k. Okay, and so if you take a higher physics course, you'll learn there's actually multiple ways to describe coefficients of friction, but for this class we're just going to focus and kind of group them all together into one coefficient of friction called mu k. Okay, and so this mu k, not to be confused with the mu used in micro, but mu sub k is this coefficient that describes the amount of friction between two surfaces. Okay, and so again, it's not just a number we assign to an individual surface. Like we can't just say, ice is, like if you have a floor of ice, right? You can't say its coefficient of friction is some number, right? Because it's going to depend on what's sliding on top of it. Is ice sliding on top of it? Is wood sliding on top of it? Is an ice skate? It's going to depend on two surfaces. So in every situation, it's going to be the coefficient of friction between two surfaces, not just one. Okay, and then the idea is the larger this coefficient is, the more friction there is. If this coefficient gets towards 0, then the surface is frictionless. Okay, and so again, this is kind of an abusive notation, but the idea is, right, mu sub k is what we're going to use to describe how much friction there is between two surfaces. Okay, and so based on that coefficient, if we're trying to determine how much force of friction we have, okay, then the following equation is what we use. Okay, so the friction force, okay, force of friction is equal to the coefficient of friction times the force of gravity. Okay, and so let me label this for you. So this is force of friction. This is the coefficient of friction that we talked about. And this was the force of gravity, okay, or the object's weight, basically. All right. And so if any other high school teachers watching this, they're just cringing because they know this isn't the real equation. Okay, it's actually really dependent on the normal force. But in all the problems that we do for this class, the object's weight and the normal force are just going to be the same, just in opposite directions, right? One's the gravity's going to push down, the normal force is going to push up, right? So for my class, we can just use force of gravity. Okay, just keep in mind in reality it's the normal force, and as you get into a higher physics class, that's going to be really important. But for now, we can just leave it as this. Okay, the force of gravity times the coefficient of friction is going to give us the force of friction. Okay, and if you think about it, this makes sense, right? Because it's going to depend on how smooth or rough the surfaces are and how hard they're pushing towards each other, which is going to depend on the object's weight. Okay, so basically, if you want to think about it conceptually, how hard something's pushing times by how smooth or rough it is gives you how much friction you're going to get. Okay? All right, so that's our equation. Let's go ahead and see how we can use this in a example problem. Okay. So an object has a weight of 46 newtons as shown. If the coefficient of friction is 0.4, what is the net force for the object? Okay, so we got this force diagram. Okay, we know that it's got a weight of 46 newtons. The normal force is going to be pushing up with the same amount. Okay, and something's pushing it to the right with 35 newtons, but we're wondering how much friction we got. Okay, we don't know how much friction we got yet. Okay, but we can calculate using this new equation that we just found. Okay, so what we know is that the force of friction equals the coefficient of friction times the force of gravity. Okay, well, we know the force of gravity right here is 46 newtons. We know the coefficient of friction is 0.4, so we plug those guys in. Okay, and that will give us 0.4 times 46 newtons. Okay, you times that out. We put it in our calculators. And we get 0.4 times 46 gives us 18.4 newtons. Okay, so that's how much friction is on or pushing on the object, right? So this is going to go right there. Okay, so this is 18.4 newtons. Okay, so if we're trying to find the total net force on the object, all we got to do is take this force right here minus that force right there. Okay, so we do 35 newtons minus 18.4 newtons, and that will give us, put it in our calculator, 35 minus 18.4 gives us that the total net force on this object is 16.6 newtons. Okay, and so there you go. So you just calculate the friction force, take the difference to get the net force, and now we know how much force we got on this object. Okay, but notice something. Okay, all we needed to determine how much friction force we had didn't depend on how hard we were pushing on it. It just depended on the object's weight and the surface. Okay, all right. Oh, and also one more thing to keep in mind. Notice that the coefficient of friction doesn't have any units. Okay, that's why it's called a coefficient, because it's unitless. Okay, it has no units. And that makes sense, right? Because we start with weight, which is in newtons. We end up with force, which is newtons. So we wouldn't expect any units on the coefficient. Okay, and so just keep that in mind. Coefficient means no units, basically, in physics. Okay, let's try another one to see if we got this down. So a polar bear sitting on a sled has a mass of 450 kilograms. If the coefficient of friction between the sled and the snow is 0.7, how much force is needed to get the sled moving? Okay, so let's draw the force diagram first to make sure we got this. I'll do this in, I'll do it in white. So we got the polar bear sitting on the sled. Let's look at the force diagram. Okay, so there's going to be that gravitational force. Okay, force of gravity. And we don't know exactly how much that is yet, but we do know the object's 450 kilograms. Okay. We got, you're trying to push it, right? And you also know there's going to be friction. Okay. So you got friction force, you got applied force. And then, of course, we got the normal force. Okay. Coming out as well. So pretty much this is a well-balanced diagram, okay? And so what we need is we need to figure out, first of all, how much gravitational force we got. That's going to help us figure out how much friction force we got, and that's going to help us figure out how much force we need to apply, okay? So let's start with figuring out this gravitational force. So we know the object's 450 kilograms. From the mass versus weight lesson, we know that the force of gravity equals the mass times the gravitational acceleration. So that's going to be 450 kilograms times 9.8 meters per second squared. And that will give us, when we times that out on our calculators, 450 times 9.8 will give us a total of 4,410 newtons. Okay, so that's going to be the force of gravity down here. So that's 4,410 newtons. Okay, now let's figure out the friction force. Okay, so the force of friction equals mu k or coefficient of friction, times the force of gravity. Okay? That will give us, mu k is right there, 0.7 times force of gravity, which is 4,410. We times that out. Times 0.7. And we get that the friction force is 3,087 newtons. Okay? So let me redraw this because it's a little cluttered right now. Let's get rid of that. Get rid of that for a second. Okay, so if we're looking at this diagram again, a little less cluttered. Okay, we know that this gravitational force was 4,410 newtons. Okay, we know this friction force is 3,087 newtons. Okay, so the normal force is also going to be 4,410 newtons. Okay, and then if we think about it, right, if we want to get this object moving, this polar bear on the sled moving, okay, we at least have to push with as much force as the friction is going to give us. Okay, if we don't push with at least that much, we're never going to move. Okay, so this is going to be anything greater than 3,087 newtons. Okay, any number greater than 3,087 newtons. Well, in physics, we don't like to write greater than signs a lot, and we don't like to use approximations and all that. Okay, so we actually will just write it like this, that at the point of 3,087 newtons, even though that's when it's officially balanced, to answer this problem, that's the point, you could say, where it has to be balanced. So to answer this problem, we would just say 3,087 newtons. Okay, that's our answer. Okay, now you're thinking, well, that's not really the answer, right? Because that's where it's balanced. But in physics, we like to say, well, that's the point where it will start to move after you get more force than that. And so even though, yeah, it's greater than 3,087 newtons, that's how much we'll say for this problem. Okay, it's just a weird little technicality with physics, but just keep that in mind. So yeah, it needs to be a little bit bigger than that, but that's the point where it's going to start moving. Okay? All right, so let's summarize this problem because it's a little messy. Point is, okay, found force of gravity using the mass, found the friction force using the force of gravity, and then compared that to the applied force, which in this case they'd be the same, to give us 3,087 newtons. Okay? All right, let's try one more. Hopefully this one will be a little less cluttered. Okay, so let's try this problem. So a car driving down the road to the right has a free body diagram shown here. Okay? What is the coefficient of friction between the car and the road? Okay, so in this case, we need to make sure we know what we're looking at. Okay, so here's the car driving down the road. It has a certain amount of weight. It's driving to the right, and the road is giving it some resistance, right? So we need to identify, first of all, this is the force of gravity right here. And this is the friction force, okay, because the car is driving to the right. Okay, so that means this is going to be the applied force, and this is going to be the normal force. But the ones that we're really worried about are gravitational force and the friction force. Okay? So what we're going to do is we're going to say, well, the force of friction equals mu k times force of gravity, coefficient of friction times force of gravity. So what we want to do is we want to solve for the coefficient of friction. So we're going to divide by force of gravity over here. So that's going to give us that the coefficient of friction is equal to the force of friction over the force of gravity. Okay, and in this case it's really nice because we're given that the force of gravity is 9,700 newtons, the force of friction is 500 newtons, so we just gotta plug it in. Okay, so that's going to give us 500 newtons, okay, over 9,700 newtons. Okay, we put that in our calculator. So 500 divided by 9,700. That's going to give us a coefficient of friction of about 0.05. Okay. And notice, again, coefficients of friction don't have any units, right? So when we did this division, the newtons are going to cancel out, which leaves us with no units. Okay, so that's right. So coefficient of friction is right there, 0.05 newtons. Okay, so if we want to rewrite it, mu k equals 0.05, or not newtons, just 0.05. It's a coefficient, right? No units. And there we go. There's our answer. Mu k equals 0.05. Okay? So there you go. So the thing that's interesting about friction and problems with frictions is they're all different types of problems. So many ways you can work with it. So we can't go through, every single problem with friction, but hopefully this gives you enough background to understand how to work with friction, how to find mu k, how to find the force of gravity, and so on. Okay? But hopefully that all made sense. Let me know if you have any questions, and thank you for watching.